Hello everyone, this is an introduction to Pandas. I will be discussing some slides and following along in a Jupyter notebook that I have also provided for you. We are not talking about these pandas, although they are cute and adorable, and I'm sure that we could find a course at UC that studies them, but we will focus on the Python Pandas library instead. We're adding another import statement to our notebooks. We will continue to import NumPy because we revert back and forth using NumPy data structures and NumPy objects. So let's add two import statements to our notebook. There they are right there. Click Run. The first thing of interest is the concept of a series. It is a linear or one-dimensional array. It can be heterogeneous. It can have different data types and different elements of the array. That makes it different from a list. And it makes it different from a NumPy array, not a list. We can also create semantically interesting indices rather than just integer indices. Instead of just starting from the integer 0 and indexing numerically, we can use character strings or other useful data types to index into our series, and then we can transfer that into the data frame so it begins to look more like an Excel worksheet. Here's an example of a series. We have not yet defined an index. We'll do that in a moment. Notice that it is a list inside of the parentheses, so we're passing a single object really to the np.array method, and then that single object is a list. The comma separated elements in the list become the rows for that series. And then if we print that out, it prints it vertically so it looks like a column. And then later on we build those columns into a data frame and it starts to look more like an Excel worksheet. Notice in this particular example that the elements are heterogeneous. We have at the very end an integer after a whole bunch of strings. And since there are strings in there, and since it is a heterogeneous array, it decided to make that an object. Okay, so the np.array function studied the data and made its best guess that, hey, there's not much I can do with this, so I'm going to make it into an object data type. That's the most general, non-specific data type that we have, and that's perfectly fine. Nothing wrong with that. But I like to emphasize data types because that's the way that programmers relate to things. And since we don't explicitly declare things in Python, since it's a dynamically typed language, I think it's important to always talk about data types. Now I'm going to modify this just a little, simply to illustrate how Python does indeed study the data that you're presenting to it when you're creating this series. I've modified this little code snippet to have 3 integer values instead of a bunch of heterogeneous values. And then when I run that, we're going to notice that it decided that it was an int32 array of things. Again, just in keeping with our theme of trying to understand the underlying data types behind the programs that we write. If I put decimal places after these numbers, it looked at the numbers and it decided that that series should be a set of floating point values. So float means floating point, it has a decimal point in it, and the 64 means they take up 64 bits in memory. The nuts and bolts of that, not really important. Just again, keep those data types in the back of your mind, and I think down the road it will always help you if you understand what data types you're dealing with, because sometimes they have to match. Sometimes you can't do operations unless the data types are equivalent, and sometimes you may need to convert between types or start out with a particular type. Also notice in this example that the index created for us and displayed when we did the print statement is simply an integer index starting at 0. Okay, that's what we're used to. We index from 0, incrementing by 1. But in the case of a series, we can add a custom index that has semantic value. In this example, I've created another series, and the basis for that series is a NumPy array, and the basis for that NumPy array is a list. And the entries in the list are stock prices. When I create the series, then I'm calling the series object constructor. If you're not familiar with constructors, that's okay. It's an object-oriented programming concept that we really haven't covered this semester. Don't worry about it. Here's our index. I decided that it would be semantically interesting to assign each row of that series the name of the stock ticker for that particular stock price. And then I can print that out, and you can see from the output now that there's no longer a zero-based index on the left, but the index on the left now is the company, not the stock ticker, the company name for that particular stock price. So that gives us some useful tools for selecting rows in the series, and of course then selecting rows in a data frame based on that semantic index. Notice also that it did infer the data type of that series as being floating point 64-bit because I put decimal places in those numbers. Back over to Jupyter Lab again. Let's just run that snippet of code we just talked about. There it is, no big deal. Let's be curious. What if I don't provide enough indices? There are 4 rows in that series, 4 rows in that column, but I'm only providing 3 indices. And there's my error. The error, not very helpful. Length of past values is 4, index implies 3. If you study it and you look at the code where it occurred, you can probably figure it out. It could be a little more helpful, but that's what we have to work with. So always take the time, be patient, read the error message, look at the line of code where it occurred, skip over all of this internal stuff because that is code from Python libraries that you don't have access to, that you didn't write, that you probably aren't going to be able to decipher. But if you focus on the top of the error message showing you the line of code in your program where that error took place, and the bottom of the error message showing you what the text of the error is, you can usually figure it out. And I need to go back and fix that. If I absolutely have to make this work and I don't know what that last index is, I could just put an empty string in there. Now I have 3 rows with indices that are meaningful, and then the 4th row has a blank or empty indices. It does have one, it's just empty. Let's put that back the way it was so it looks pretty. Okay. Here's an application of that index. And if you look at the syntax here, there's the square bracket indexing notation that we've seen already. So when we want to step into an array or step into some indexable type like a list, we use square brackets. And then inside those square brackets, instead of a typical indexing integer, we put in a string. So that's amazing to us, to me, because I can do semantic indexing. If I want 2 rows from the series, I can do a list inside of the square brackets and then separate those elements by commas inside that list. And that will give me 2 rows from the series. And that's, again, really powerful. As long as I know what the names of those rows are, I can index as many rows as I like. This syntax to me, again, let's just quickly touch on it. The outer brackets here are telling Python that we're creating an index into something, a list, a NumPy array, a dictionary, a set, whatever. And then the inner square brackets are telling Python that we're creating a list. And I think it looks like we're using square brackets for 2 different things. And that requires you to stop and think a little bit. What do the outer brackets mean? What do the inner brackets mean? Just be careful with that. And of course, we'll go back to our code. Here's that little snippet of code right off the slide. And I get, as we expected, for the first one, just the column, just the stock price for IBM. The second one, since I'm asking for 2 rows, it also provides the index along with the column, the data in the column. So you get a slightly different result from doing that. And let's be curious, what if I ask for something that's not there? So what if I ask for Coke? I get a big error message. I usually just scroll down to the bottom. Passing list likes to loc or square brackets, that's square brackets, with any missing labels is no longer supported. The following labels were missing, and then there it is right there. Meaning that if I took the time to read this and I didn't panic and I got my heart rate down, I could probably figure out that, hey, I provided an index that did not exist. And that sends me back up to right there at the top of the error message, and there's the line of code that caused the problem. I can hopefully realize what I did and fix it. So that's got to come out. Now that error message makes sense in context because it's impossible to index into something using an invalid index that's just not there. Once we've got a series, we can use a set of series objects to create a data frame. Let's do that. So here's an example. I have a NumPy array of stock prices. So I'm creating a brand new NumPy array, and I went online and looked up stock prices for these companies. And then from that array, I'm going to create a series, and I'm going to, on the fly, provide the index row titles for that series. Each row is a company name. And I'm also adding a new trick here. I'm going to provide something called a name, and we'll see what happens to that in a minute. So keep an eye on that name. That's one series. Then I'll create another series. And this is a 1-column piece of data containing market cap values for each of those companies. Notice that the indices there are identical to the indices I created above. Both series have the same indices. That helps them match up. Okay, I can create a new data frame by calling concat or concatenate. Pass it a list. The first argument I'm passing to concat is a list, and inside the list are comma-separated series values. You can see there I can pass more than 2 if I like, simply by adding them to the list. And then I print just to see that everything worked out okay. Let's go back to our code again. I got a data frame. I got 2 columns now. Each column is one of the series values that I passed into concat. And then the indices, since they overlapped 100% now, the indices show up beautifully on the left side. So we've seen a strategy then for creating a series and then creating another series, making sure they have identical indices, and then concatenating them together into a data frame. Okay. This is another strategy for creating a data frame. If you don't have series or you don't want to go through that step, let's use a dictionary. Remember, dictionaries are key value pairs. In this example, the key is the name of a fruit. It's a string in quotes, and the value is some numeric thing. We'll say that those are the purchase amounts, maybe in thousands of pounds or in tons or whatever for that fruit. And then I can add as many elements to that dictionary as I like. In this case, I have 3. Once I've got the dictionary, I call the data frame constructor. Constructor being an object-oriented programming term, you can just gloss over it if you're not familiar with OOP. We're not covering that this semester. Pass it the dictionary. The data frame class processes that dictionary and creates a data frame. And then I print it out just to look at it. Notice in my results over here on the slide that there is an index created by default, which, as you might expect, is simply zero-based integer indexing. Doesn't have any value to us yet, so we're going to come back in a moment and add an index to this that has meaning. Let's go back and look at our code. There's our output. Let's try to break it, because we always do. Let's just put 0 in there. We're saying that this first key value pair is guavas, and the values are 5 in count, but the other values for the other dictionaries are only 4. Let's see what that does. Again, kaboom, blew up, gave me a nice big error message, takes up the entire page. I skip to the bottom. Arrays must all be the same length. That's a pretty good error message there. And then I scroll back to the top, and it tells me that error took place in line 6, but it kind of didn't. It kind of took place earlier than that because I configured purchases. The error actually took place right there, which I guess is line 2. I need to take that out. Good. Error goes away. Back to the slides. I don't have an index yet. Remember, I was simply living with the default integer-based index that the data frame constructor provided. Now I realize let's put some semantics in there. I need to know what stores that we are dealing with. So I can set the index property of my data frame. Okay, df is my data frame. I created that a moment ago. And I can just assign a value to the index. The value I'm assigning is a list. The data frame iterates over that list and assigns each element in that list as the index for a row in my data frame. I can also give the index a name. In this case here, I'm saying the name property of the index property. I'm assigning that the value store. When I print it out, you can see that the word store appears over the index column, and we're starting to look like an Excel worksheet. Back to the code again. There it is. Of course, let's break it. Let's put too many indices in here. I can't think of the name of another grocery store, so I'll just type in my store. Now I've created a situation where there are too many values because there are only 4 rows in the data frame, but I've given 5 index values. And what do I get? Of course, I get an error, length mismatch. Tells me what line of code it took place in. And I need to say, hey, compared to the original data in the data frame, there aren't enough rows to match up with all those indices. And that needs to come out. Fix that. Back to the slides. Everything's great. I have a data frame called DF. It needs more data. I have more stores in my database. I'm going to add more rows to my data frame. My strategy will be to create a dictionary. Key value pairs, same structure as the earlier dictionary I created when I built this data frame initially. Create a brand new data frame. I call it new DF. I give it an index. I give it a store. I'm sorry, index name is store. And then here's the magic. I call the append method of the DF object, which was my original data frame, and I pass it the new data frame. Now the ignore index equals false means use the index that's in there, don't create a new one. So if I don't do that, it tries to jam some integer-based indexing in there and I get a mess. So you can experiment with that by taking out that ignore index to see what you get. It did take me some research when I first started doing this to figure out why I needed ignore index in there, but now I pretty much use it all the time because I know that both of those data frames have identical indices, and I'm happy with that. There's no reason to create new ones. Let's go back and look at our code. Here we go. This is going to get good. Now we have a data frame with 6 rows in it because I executed the append. Okay, let me just for a moment touch on a mistake that a lot of us make, that I make all the time. And that is when I call a method like append and it does something, I don't really understand what it does and I don't handle it correctly. So by way of example, let me go back over here, and I have cobbled together, okay, in a new cell, all of the code that we've just talked about. I created the dictionary, I created the data frame, I added 2 more rows to the data frame. I added 2 more rows to a new data frame. And then I got to the append. So everything is the same. The environment is completely the same. All the data is the same up to the append. And this is where we make a big mistake. At least I make it a lot. I'm going to put this print statement back in here. Notice the difference between this append and the append in the original notebook. I'm going to flip back over to the original notebook. Notice that this one has an assignment on the left side of the expression. Whatever df.append is doing, it's sending me something and I'm storing it back into df again. But over here in this new cobbled up cell, I'm not doing that. So there is no, I'm going to put a comma in here. There is no assignment of what append returns. And that's a big deal, and that's why I'm harping on it. I'm going to run this cell the new way. I'm going to run it without the assignment statement. Let's see what I get. Okay, look what I got. I got the original 4 rows that were in my new original data frame, but I did not get the 2 new rows. It looks like append didn't work. But append did work. It just didn't do it the way I think it should do it. Or the way I assumed it would do it. I'm not saying that I'm right and it's wrong. What it actually does is it creates a new data frame in memory containing the original 4 rows and the 2 new rows. Brand new data frame. And then it sends it back to me. Now I have to receive it and do something with it. Over on the original notebook, I did something with it. I assigned it back to df again. I stored it in df. Over here, I just threw it away. It said, here's your new data frame. I did the append. You have 6 rows. I said, okay, and I just ignored it. I didn't do anything with it. So this is correct. Okay, this is what you want to do. You want to have that assignment statement in there, and you want to receive back what comes from append. It's not broken. There's no bug. That's just the way it works. And let me illustrate that a little differently here. Brand new df. And then I'm going to print all 3 of these to show you what we really have at this point. I'm going to print df. There's my original one. I'm going to print new df. There's my new one. And I'm going to print brand new df. You will see that this one has the original 4 rows. This one has its 2 new rows. And this one has all 6 rows. And there you go. And I totally messed up. You're probably yelling at me now. I typed this wrong. Hold on. So this needs to come out of here, and this needs to go here. My fault. The assignment needs to be part of the append. Okay, this will give us what we want. Let's get rid of that because that's extra.